go.
So here are a couple of things. Now, this is the same code. I'm going to tell you what the code is doing. This is Mike Bostock's code. He's trying to show how a shuffle works. And a good shuffle should be evenly distributed, by which I mean that if I have a deck of cards and I shuffle them, I'd expect any card to end up anywhere else. Now these two shuffles, it looks like two shuffles, aren't doing that. The table you can see has got 30 cards, and it's a mapping between the card and where the card is likely to end up. So in the will it shuffle on the right as you look at this screen, card 28 and 29 are likely to end up in positions 1 and 2, but unlikely to end up in positions 28 and 29, whereas card 0 is a little bit likely to end up at the end of the deck, but not at the start. So that's what this piece of code is doing. It's a naive shuffle. It's by a random comparator. And one of the reasons I use this as an exercise is to show that the same code in two different browsers can produce two quite different effects. What you're looking at here is not one randomization, it is a 30 element deck being shuffled 10,000 times, and then the proportions of that plotted on this graph. So we're looking at 900 instances on that graph, and that 900 instance graph is a summary of 10,000 separate individual tests.
Right, and in the app, we have no way of making it do more or less than 10,000.
That's right. That's how that JavaScript is set up.
Because that was one of the questions Steve had. What does it look like under different numbers of shuffly things?
You do fewer if you do more. So we'll take one of these funny ones that looks particularly interesting.
So if we do this on Chrome and inspect.
There are two browsers, are Chrome and Safari here. There's Chrome on the left, Safari on the right.
So I'm going to dock this on the right so I can maximize this. So we've got a refresh button down the bottom, which if we click should let us trigger the randomizing again.
And you can see when you refresh it takes about half a second or so, and it does make it change a little bit.
And the code for this is in the page
body
itself.
In that second scripty thing, underneath the D3 script, then there's this one script there. Yeah.
Right, so we've got code. It's not that easy to manipulate this code, but we can see the injection point for the 10,000 is in there.
Down you go, and you've got two variables cleverly named N and M. So if I know we're doing this, I'd have named them better.
Get the JavaScript console up, look for M, we can see 10,000. So if I just switch M to what value, Steve?
10?
10. Magic trick. Then if we do refresh again, that's where it looks like on 10. Is that good?
No, I'd be very surprised, but that doesn't look like it makes any sense, because it means that element 29 has not ended up anywhere, nor has element 0. It appears to have deleted the thing.
Do you get the same ones?
Can we try M equals 100 just in case?
Let's do M equals 100.
Yeah, I think we've stuffed it in some fashion, because this wasn't what it was doing earlier.
So M equals 100 is giving us the same.
Shouldn't there be some green on there?
There should be some green.
So nothing's going to end up anywhere. It's like, oh, you dropped them all.
So if I go back to M equals 10,000,
I think what
if
we're
this is working, then we'll get the same result. So that's the 10,000 again.
Okay.
So maybe the code has some problem on 10.
There's some problem around 10. Try knocking it down by 10 there.
So 1,000.
Yeah.
See, that's the kind of help I need.
Big numbers. Thank you. Yes, give Alan a number.
Maybe it only works on 10,000.
That'd be strange. Would you try putting M back to 10,000, please? So what Alan's doing, changing the JavaScript of the page, and you're hitting refresh to reload. What doesn't reload it, it reruns the JavaScript. Change that N, the one above. N equals 30. N equals 40.
And what does N do?
N is the number of cards in your deck, so it should change how that table looks.
Alright, cool, let's try that.
And it doesn't. Is it back yet? 40, let's see, it doesn't go by the square.
So maybe,
so
maybe your refresh doesn't call all the JavaScript needed to set this up.
Yes,
so we have to do this then. Yeah. So this approach to hacking it isn't working. So we need a different approach to hacking it.
What's your approach?
Well, if we go into sources,
Yep.
then we should be able to stick breakpoints on this. So you've got this embedded in the main code.
That's it. Yep. It's not taken in as a separate script. It brings D3 in as a library, but then the script we're looking at is just under the D3
Yeah, let me
library.
scroll down to where M is set. Shout if you can see, there it is.
There it is.
So let's
Line
stick a
107.
breakpoint on there.
Yeah.
So this time we refresh the page, right? The debugger is going to kick. We're on M.
Mhm.
I'm going to step over M. So M should currently be set to 10,000. Let's have a check. Right, so we've got now if
Yeah.
we set M to, what was it, 100? Let's try
Mhm.
100. M is 100. If I let the application run,
Boom.
so does that look better?
That
Okay.
looks more like it's got as much green as red.
So your refresh doesn't do a
Right,
full
don't
refresh
do it.
because it's not expecting anyone to hack the underlying variables that it sets
Yeah.
as global.
I must have a look at that refresh button. Or rather, at Mike Bostock's refresh button, because all credit to Mike for some of this. I've fiddled it so it's good for testing.
Right.
So I must spend more time with the code.
Cool.
So you've set a breakpoint, and
yes.
once the value is set, so it actually exists, you then you go
Yeah,
to that and
so-
then you skip one over. Then
So
you
one
can
thing,
change it.
yeah. So one thing you mentioned was changing M. So we could try this again and actually change M and
Let's
see if
try
your
that.
system does handle multiple grid sizes. So if
Sure.
so N is set to
Because I've picked these. Right.
N is not defined, so N should be defined now. That's too fast.
Yeah, I was going to say, did you go in
That's
before it
interesting.
jumped over the breakpoint?
So the breakpoint kicked in before the page had refreshed.
That's interesting. All right. Yeah.
So N equals 40. We'll try that.
Yeah.
And I'll set M to 1,000.
Yep.
May as well change all the variables at the same time because that's what a good experiment does, isn't it?
Mm-hmm. I mentioned the one underneath is called zero. It's a
so
good variable name.
Did you spot the mistake?
No. You need a semicolon.
Right, no. So if I step over
Yeah.
and look at M,
Yep.
M is
and
10,000. I've
because
set
you-
M too early.
Yes.
Right, we
yeah, yeah.
haven't gone over.
Yeah, we haven't
So
jumped over it yet.
I'm going to set it to 1,000.
Now we do. Thank you. Huh?
And then it returns. Let's see if it handles a grid of 40. This is new.
It's gonna
James
handle
hasn't
it.
seen
It's gonna
this.
handle it. I've played with this. Yeah, go on.
Right, there we go. So there's a
There we
grid
are.
of 40.
It's grid of 40 and 1,000.
Yeah, and that's how you push applications beyond their limits when they're not designed to be
Mhm.
tested. There's always a level we can test under.
Mhm.
And in this case, we've had to not actually amend the source code. We're
Mhm.
we're not touching the source code at this point. What we're doing is because it's in memory, we're breakpointing at certain points and changing the variables that are in memory so the code is running against a different set of data. It's kind of just a different way of injecting data into the application, but we're injecting it into a place where the interface is not accessible. The memory interface is not normally accessible, except in JavaScript. It's one of the few systems now that we can actually mess with the running memory with the tools that are just there.
And the browser tools here, they let you mess around with the HTML. They let you mess around with whatever's on the page, but the JavaScript, it doesn't want to rerun it.
So
That
if
was
the,
problem we were having
if the
before.
person writing the JavaScript had written it in a way that was testable,
Yeah.
right, then
Testable in this fashion.
yeah, but testable. So there's no unit test for this.
Absolutely.
Right, and the reason we know that is because you can't actually test it from the console.
Mhm.
If it's possible to test it with the unit tests, chances are that refresh function
Mhm.
would have code in it. There would be a setup method that would set the variables.
Mhm.
We could overload that. Right, in that console I could say setup method equals new equals function,
Mhm.
put a new function in and just put new code on top and run it against that.
Got
Have
it.
the refresh. Or we can change it in memory.
And one of the things we were talking about earlier on was to see what events are attached to what button. Can we look at that refresh button and see what event is attached to it?
So you can, and what is interesting with this one, let's have a look. Inspect.
Inspect.
Let's see where it says. So it's over here on the right. Event listeners. Click. But where is that?
Looks like it's in D3.
Exactly. That's not the code that you have written.
No.
So what is it doing?
I don't know. I don't know, because this is a little bit of code that lives in a complex infrastructure. Part of that infrastructure is D3. What happens if you flip down the handle on button? What does it tell you? Does it tell you more about the object that is button?
Yes, it does.
Ah,
And
okay.
it shows us a function in there.
Yep.
which has prototype the order. No idea what this is actually saying. To read this function.
This is where I want to click your machine.
Yeah, you could do.
Yeah, I'll tell you what. I'll go in on my machine. I'll have a quick look. Because I'm using Safari. Nobody can see this on their machine, on the screen. But exercises.wordpress.com.
So if I click through, we see the minimize code. I can print it.
Mm-hmm.
But that's not code that you've written. So that is then looking for something, I think, to apply some method to. So there's some other stuff that's been set up magically by JavaScript. Because JavaScript does magic.
Oddly enough, if I'm in Safari, I notice that my event listeners, because I'm using a different browser to Alan, my event listeners here are click, which tells me that that's something about a button, but it's also got a listener on key down and on submit, which wasn't coming out in Alan's dev tools. It goes back to what we were saying. Sometimes these tools just lie to you.
So where are you seeing that? So I've got Safari up. Where are you seeing that?
If you inspect element and you choose node.
Yeah.
So choose up in next to styles. You've got to drop down.
All right,
choose node, top bit there.
Event listeners.
And now you've got event listener. So you've got to click. Now yours says context menu. Mine says key down and submit. And we've both got button ID refresh selected, and we're both in the node area. The identity element button. I don't know.
What's interesting is the click event is bubbling up, so I'm wondering if something in the DOM further up has got that.
He's picking that
code set.
Yeah. But the key down seems to be at a document level, and submit is also at a document level, whereas the click is on button hash button.
Alright, but that's interesting. The dev tools are showing us different insights into it, and what it also demonstrates is how little we understand.
Yeah, absolutely. Well, that's always a good thing to demonstrate.
On this,
yeah.
So we have more research.
You're on Safari 10. I'm on Safari 9.
Right.
That's one big difference that we're on. So our dev tools may be different because we're working in different.
And that's Chrome.
Yep. This is
Chrome.
Chrome. Right. So that's fun. So
yeah.
good.
Yeah.
Hit stop.